All right, everybody. Here we go. Worksheet 3, I think this is called. Unit 1.3 or something like that. Let's see if we can fly through this. So we have a data set here. Time and position. Remember, position goes on the y-axis. Time goes on the x-axis. In case you've forgotten, it's been a while. So let's see, time in hours. Let's see, let's go by, see, I have a grid of 8 by 8, so I'll go by ones. 1, 2, 3, 4, 5, 6, 7, 8. And then position, let's see, goes up to 24. I've got a grid of 8. Oh, let's see, I can go by threes, I suppose. So 3, 6, 9, oh boy, 9, 12, 15, 18, 21, 24. Okay, plotting some points. Here we go. 1 hour, 9 miles. Let's see, 2 hours and 12 miles. 3 hours and 15 miles. Oh, look at this. This looks pretty simple. Good thing I went by threes. That's pretty easy. And 5 and 21 and 6 and 24. Oh, look at this. This is pretty darn good here. Oh boy, now I got to draw a best fit, and I don't even have a straight edge on. Oh my gosh. Hold on. No, that might work. Let's see. This might work for a straight edge. Oh, I got a bad feeling about this. You can't see it right now, but I've got a piece of mail on my iPad screen that I'm, oh boy, hold on, undo. That was terrible. Let's try one more. And, oh, it was close. You know what? I gotta try one more. And we'll go with that right there. Oh, what in the heck is going on? I don't like this. Oh my gosh. All right, this is it. This is the one. All right, good enough. Oh, let's see, and that kind of goes down in here around in that range there. So, back to the questions now that I actually got this sucker plotted and I got the best fit drawn. Where did the object start? Now, I hope by now you remember that starting position is, again, the position. Oh my gosh, I just noticed something. Oh boy, I hope somebody out there is thinking about this. I did not label my y-axis. I got in such a hurry. Incidentally, I am at my home right now. It's, oh gosh, 10 after 10 at night, burning the midnight oil here, bringing you guys some rockin' physical science here. So again, position, time. I'm looking at where did it start. I want to know the position at time 0. And again, time 0 is here. Oh my gosh, I didn't put a 0 there. I guess I could put a 0 there. That's for time. And I could put a 0 there. That's for position. So, at time 0, I look up and my line crosses the y-axis at about 6. So, where did the object start? It looks like about 6 miles of position is where the object started. How fast is the object going? And in what direction? Well, let's see here. If I... Whoa, I don't know what's happening. If I start here and I use that because it looks like it's right at the 6. And then it looks like I'm hitting right at that place right there. So I'm just going to use the full line on my graph here. And again, I need to find a rise and a run. And my rise, I'm starting at 24 at the top, and it goes down to 6 at the bottom. For those that are following along at home, that is 18 miles for my rise. My run starts at 0 and goes to 6. That is a run of 6 hours. So, apparently, whatever this thing is, has gone 18, oh my gosh, has gone 18 miles in 3 hours. What does that equal? Well, last I checked, that's 6 miles. Oh boy. Yeah, I guess I'll do that. Miles per or for every hour. That is how fast. Now, what direction? Remember, direction is the way that the line is tipped, and this is tipped up. That's a positive slope. So this is in the positive direction, okay? Positive direction in 6 miles for every hour, 6 miles per hour. Okay, so after 10 hours, it says, of travel, where would the object be? Well, if you hadn't noticed here, my graph doesn't go up to 10. I don't know where it's going to be out at 10. That'd be 7, 8, 9, 10, and I don't know where that's going to be. That's going to be way up off my graph here. So how am I going to figure this out? Oh boy, you may have guessed it. Maybe you already did this. I hope you did, because this was homework for today. Y equals mx plus b. Now, the y in this case is what's on the y-axis? Well, position. Okay, so position equals, why does it, oh goodness gracious. There we go. Position equals, and the m is the slope, remember. M is the slope, which we found over here. So that's positive 6 miles for every hour times the x. And what's the x? The x variable is the time. That's on the x-axis. Plus the y-intercept. Again, remember, the b is the y-intercept, which is where our line crosses the y-axis, which is 6 miles, which again was our starting position. So now what? Oh boy, it looks like I'm going to run out of room. They want to know where after 10 hours. So where, again, where is the position? Where position after 10 hours? So what do? Well, we put 10 hours in here for time. 10 hours for time. Everything else stays here. 6 miles for every hour. We have plus the 6 miles here. And that's going to equal position. And so what do we get? Well, if you take 6 miles per hour times hours, hours cancels hours. We get 6 miles times 10, that's 60 miles, plus another 6 miles. That's for a total of what? 66 miles. And that equals position. So that is how you can find out how, or I should say where the object is after 10 hours of travel. Hope that makes sense. Moving on. Next page. Okay, so next page, data set 2, problem 2 here. Oh boy, let's see. Oh, look at that. I have 8 minutes for time. So again, I'm going to put time down here on the x-axis, which is where it belongs. I'm going to put, oh, that's in minutes this time. I'm going to put position over here in meters this time instead of miles. And I'm going to call this, I'm going to go by ones for my interval. 1, 2, 3, 4, 5, 6, 7, 8. And I'll need all 8 of them this time. I only needed 6 of them last time. And let's see, I got to go up to 27. Up to 27 on my position, so I'll guess I'll go by 5s. 5, 10, 15, 20, 25, 30, and that should do it. So I got to plot my points, and my points are 1, 27. So I put 1, and then 27 looks to maybe about like that. And then 3, 21, which looks like it might be about like that, somewhere in that range. 4:18, which could be about, here maybe. 6:12, maybe about in this range. And 8:06, which would be maybe about there. So my points are plotted. Let's see if I can screw up the best fit about 16 times again this time. And oh boy, I'm trying to put this piece of mail on there. I'm trying to draw. Oh my gosh, that's pretty good. People, my gosh, have you seen a best fit drawn with a piece of mail that looks any better than that? I don't think so. Oh my gosh, look at that. It's crossing right up here at the 30 area. We're probably going to need that information because it says, where does the object start? Where did it start? Again, we're talking position here. When the time is all the way over at 0. When time is 0, you go up till you hit your line and you see it's at 30. 30 what? 30 meters. You better make sure you're using units of measure. 30 meters is the starting position. How fast is the object going? And in what direction? This sounds like a slope question again. So I want to know, how fast is it? Well, I need to find some places I can actually use to find slope. Oh man, I don't see it. It doesn't hit the grid intersection on any of these. But I tell you what though, it does hit my data point over here, which I know is 6. And it hits up here at 30. So let's see how this works. I hope you're going to follow along with me here. I'm going to say that my line starts right there, and then I'm going to drop this down from here. So I hope you're seeing right now I have my triangle here. Okay? Now, how tall is my triangle? Or I should say really, it's a fall instead of a rise, but this right here, I'm starting at 30 at the top, and it goes to 6 down at the bottom. So how big is that? Yep, that's 24. 24 meters. That's my rise. How big is my run? Well, starting at time 0, ending at time 8. 8 minutes. Oh boy, did I say seconds? So my run is 8 minutes. That's my run. What am I going to do with that? Well, I'm going to say 24 meters over 8 minutes. What does that equal? That looks like it's going to be 3 meters for every minute. Oh, there we go. So, hold on. There. Okay, that's an I. There we go. So, 3 meters for every minute. That is how fast. Now, the question of what direction. This is important. What kind of slope is this? Oh, which is something else I should have done. My goodness. The change in position here, if you'll notice, it starts at 30 and it goes to 6. That, the delta x, I don't know if you guys remember this, but I hope you do. The delta x is the final position minus the initial position, which in this case, where is it final? The final's down here at 6. Final position of 6 meters minus the initial position, which was 30 meters. 30 meters. So 6 meters minus 30 meters is negative 24 meters. So I should have had a negative sign on here, and I completely forgot. Negative 24 meters. Because again, it is a negative change in position. Starts up here and ends down here. That is a downward change in position, which is negative, which means then that this should be a negative 24 in here, which means that this should be a negative 3 meters per minute. Negative. Don't forget the negative. So that's the direction. How fast? 3 meters for every minute. In what direction? Negative direction. Okay. To number C, or that's not a number, to letter C. After 10 minutes, again, if we look at the graph, it only goes out to 8 minutes. I don't know where it's going to be in 10 minutes. So I'm going to have to do some figuring here. Let's check this out. We're going to need the y equals mx plus b again. And I have to rewrite this equation. So I'm going to go with, let's see here, position equals, again, because that's the y. The y part is the position. The m part is the slope. That's this. That's a negative 3 meters for every minute. And I'll put that in parentheses. Times the x, again, which is the x variable, is time. That's the variable on the x-axis. And I can't forget about the b. I have to add the y-intercept, which we wrote down up here. That's, oh my gosh, that's 30. Oh, that's totally messed up. 30 meters, okay? Now, if I want to know after 10 minutes, where would the object be, then I'm going to have to plug 10 minutes in for time and do the math. So I'm going to keep all this stuff, 3 meters for every minute. That's position. 3 meters for every minute times the time, which was 10 minutes, plus the 30 meters, which was the y-intercept. I can't forget that's there. And you'll notice that when I take 3 meters, I should say negative 3 meters for every minute times 10 minutes, my minutes cancels, and I get negative 3 meters times 10, which is negative 30 meters. Plus, I can't forget my y-intercept out here, plus 30 meters. Are you seeing what I'm seeing? We have a negative 30 meters plus a 30 meters. Where is this thing after 10 minutes? It's at position 0 meters. It gets back to the origin, the 0 position. That line, if we could continue it, it's going to go, 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 and then when it hits the x-axis, or the time axis, I should say, it's going to be over here, which is right about at 10 minutes. Oh, that's fantastic. Isn't that just wonderful? Next page. All right, folks, this has been a long video, but there's more. So, I don't know, maybe I have to break this up into more than one. Oh my goodness gracious. Oh boy, position time graphs, okay? We have to translate what that is to velocity time. Now, the first part here, again, what kind of slope is that? I'm just going to start writing some things down. That is a negative constant slope. What kind of slope is this part? That's a 0 slope. What kind of slope is this part? That is a positive constant. So when I go over to this graph here and I'm trying to figure out what my velocities are, if I know negative constant, then that's going to be a line that's below the time axis, and constant meaning it's not going up or down. It's not going up, line's not going down, so it's constant. The next part, this part, is a 0 velocity, therefore it has to be on the t-axis, 0. The next part is a positive constant velocity, and so that's going to be like here. Now, if you're looking at this, you might be thinking, that doesn't seem right, because if I look over here, this part is not as steep as this part. This part's way steeper than this one, which means this one is going to be faster. I hope you were thinking that. So this part, oh boy, hold on. What is happening here? Oh no. Oh, what the? Apparently I can't grab that line and make it where I want it to go. It won't let me. I don't know how to do that. I wonder if I can erase. Can I erase? I don't even think I can erase on this thing. I don't think I can erase. What the? Maybe this is it. Is that an eraser? No. Oh, I tell ya. Oh, that's not working at all. Okay, well, anyway, I hope you get the point at this. Oh, this is not working at all. How do I, wait a minute, do I do this? Can I, no. Oh, no. Nope. Arrange, how about, no, that won't work. This is not working at all. Oh, well, I can move all of them. That doesn't help. Well, that stinks. Okay. Pretend that's not there. I should have put that up here further. And again, why is that? Because notice, this part, the negative part over here, is not very steep. This part is very steep. It's faster. It needs to be further from the t-axis than this one is from the t-axis. The negative one is slower. That's closer to the time axis, to zero velocity. This one is further away. That means it's faster. Okay, moving on. We may have to go faster this time. I said faster. This right here. What kind of slope is that? Positive and constant, which means this better be above the t-axis. Positive and constant. What kind of slope is this part? That's negative and constant. And notice that's not happening for as long as this one. That's a shorter time. If you look at time here, this part here is only happening for if that, oh my goodness, if that right there is, this time interval is way longer than this time interval. So I have a positive, then I have a negative velocity that is not very long. That's going to be maybe a short one like this. And also notice, this is about the same steepness as this one. So I put this one about as far away from the time axis or from the zero velocity as I put this one. Because you have to remember, that's zero velocity. Positive velocities are up top, negative velocities are below. So 0 here, positive up top, negative below. 0 here, positive up top, negative below. Now, one more section. What kind of slope is this? That is a zero slope. Zero slope means we better have zero velocity. That means it's on the time axis. So that's what that one should look like. Last one. Here we go. What kind of slope is this? That is a positive constant slope, which means above the time axis in the positive range. What kind of slope is this section? Zero slope. That means the velocity is 0 for that time interval. And then lastly, we have this one, which is negative, and I'm going to have you notice it's way steeper than this one. This one is steeper than this. So the negative slope, negative constant velocity is steeper and therefore faster than the positive constant velocity, which means my line is going to need to be further away from the t-axis, like down here maybe, than this one is above the t-axis. So my negative velocity is more like this. Definitely faster because it's further from the zero. Faster negative, slower positive. That's what that's telling us. I hope that this helps. I don't know, you may want to go back and watch it again to make sure you're kind of getting all the pieces and parts. But that should help with this little worksheet.